them in.
This is my warm-up. Very nice.
Okay. So, each one of these should have been 4 different concepts that happened to the sinusoidal graph, the sine wave. I'm going to give you guys 4 vocab words. In your group, you guys have 1 minute to try and figure out which vocab word applies to which transformation I did for my graph above. There's your 4 vocab words. Hey Siri, set a timer for 1 minute. I don't know, because we can still need to have the equations in here. Okay. Person in the furthest row away from me on the right-hand side is going to be speaking for your group. When I ask for the very first vocab word, you are to show me. Watch your language, back up.
I didn't say anything.
Your mouth.
That was good.
You are to show me fingers of which number that word applies to. Please, when we get to number 1, you are not allowed to use your middle finger to give to me to tell me which number it applies to. Any questions? No?
You just gotta watch Becca, apparently.
Look, yeah, she'll just mouth it.
I will. Maybe.
Number 1, or excuse me, phase shift. Which one does phase shift go with?
Oh, are we supposed to right now?
What are you holding up? You got like 2 and a half, 2 3/4, what?
I was partially group, I got partially in, I guess.
Okay. We are all over the board on here, except Addie is correct.
Yeah, Addie!
Oh, I didn't know we were supposed to be holding up numbers. I thought we were just holding up.
Okay, thanks for not listening.
Please.
Number 4 is a phase shift. The theta plus 3 should have moved the thing over. Reflected on the x-axis, please show me your group's number. Wait for all votes to be in. All votes. Wait for all votes. Number 2 is correct. amplitude. Watch it, Becca.
I'm not gonna do it.
Elena, which one is it?
1.
Why is it 1?
Because it like moves the.
It what?
Moves the 3 moves the thing up.
Oh, makes it taller.
Yeah.
And then I guess period would have to be.
3. Oh. Yeah, Cameron.
Just wait for everyone. You don't have to put your hands up there. You're not allowed to vote.
Oh. Oh, wait.
Thank you. Way to double check your math and count to 3 twice on your hand. Okay.
Gotta go.
So, let's see if the pictures what they should have looked like if you did it correctly. So, the blue one, it makes it taller, right? Therefore, it affects the amplitude. How do we measure amplitude? Second? The height from where?
It's 1/2 the distance from the crest to the trough, or like the top
Yeah.
and the bottom.
Or it's the height from the distance away from the x-axis, right?
Yeah. Or is it the distance from the midline?
Yes. In this case, it's the x-axis, but when we start shifting it, yes. Negative x, negative sine x.
Moved it over pi or reflected it.
Reflected it, or moved it over 2 pi. T-O pi, not T-W-O. What did this do to it? Increased frequency, it happens twice every 2 pi instead of once, or the measurement from 1.00 to the complete cycle being done is pi.
And the period was.
And this one.
This one's kind of hard to tell.
They moved it from 0 over to wrong graph.
-3. Something. You're doing so. I said 3 at one point.
It is. It moved over 3. All right. So what you guys did as a warm-up today was 3 different types of transformations of sinusoidal waves. We just did a reflective one, which also we could just do a phase shift description of the translation on that one. Any questions on that? So we're going to be talking about sinusoidal waves. Let's make sure we know what we're talking about. Last week, you guys talked about circles. We even made a unit circle. You guys remember that?
Yeah.
And we talked about how angles can spin under the circle multiple times and we can figure out the final ending measurement. We talked about like a clock, correct? You guys remember that? Good. So, my little sneaky demonstration is basically we see a circle here. Okay? It's a circle. And I have it stacked, so there's multiple circles that we've done multiple times around there. But it's always a circle. Does that make sense? Good. So, today, what we are going to do is take my circle and unravel it linearly.
Let go. Please don't let go.
We are now looking, we got a little hook up in there, 2 of them, but we got a linear representation And if you kind of look at it a little bit at 45 degrees, it looks like a
Sinusoidal wave.
sine wave.
Oh, I see it.
Look at it. Yeah.
So what I'm trying to show you is how we went from having a circle, and when we spread out linearly just like the slinky, we're now making sinusoidal waves. Izzy, Rosie, go ahead and let go.
No. Leah, move your water
Ready?
bottle.
1, 2, 3.
Let go.
Ready? 1, 2, 3. Let's go.
You're so messed up.
Oh. I was not.
You're acting weird today.
Okay, so I want to talk about sinusoidal waves. Sinusoidal waves. A sine bx plus c. Each one of your graphs that you did today hit on one of those three components or transformations. This week's assignment is completely based on A sine of bx plus c. Let's figure out what each piece means. The A, which should be pretty easy to figure out, is what, Carson? Thank you. The C gave me what? The phase shift. But the answer wasn't really C. What was the math that I had to do for it to get the phase shift?
It's H.
It was minus C, right? Now, if you use the letter H, you're already going to write it as minus H. I don't know why sometimes they use C and sometimes they use H and K. So you're also going to have to realize that that would be H if they had H in the equation instead of C. Yeah.
But the equation is still plus C instead of minus C.
The equation that we're going to be working with is just going to be A sine bx plus C. Next week they started introducing H and K and then they changed it to bx minus H. And I do not have a clue why they can't just keep it consistent for both instead of have two different systems.
Yeah.
I'm sorry, that's just the way the
So
thing works.
C is still negative H? Or is it?
I'm just writing minus H.
Yeah.
Okay,
Just for me.
that's great. Now B helps me find the period, but B is not the period itself.
It's 2 pi over B is the period. Right?
A typical sine wave has a period of 2 pi. When I write a new B in there, all I have to do is divide that 2 pi into whatever piece the B tells me. Huh?
I said because 2 pi is a circle.
That's right, exactly. Which was what everything goes back to. Now there's some term that we haven't really worked on very much. Is the frequency, how often it happens in a 2 pi cycle. So the formula is just B over 2 pi. dissected. Every single problem of your short 58 problems this week is referred back to this right here. The dissection of the sinusoidal wave. What'd you say?
This is a really bad day to miss.
It happens. So let's talk about some of the ways that we can actually apply this. Suppose I give you an equation like this, graph 2x or 2 sine x plus 1. Actually, and I don't want you to do it on your computer, sorry. So let's change the rule. Sketch it. Just by what you know. Does anybody know information out of this thing right here that we could pull for A, B, or C? What do you got, Shauna?
Its vertex is going to be -1, 0.
So we know it's going to start at -1. Bailey, what do we know?
The amplitude is 2.
So we know it's going to go up to 2 and down to 2. What else do we know? Bailey?
The phase shift is.
We already got the phase shift.
Oh, she said that.
Izzy Rosie?
Its period is 2 pi.
What's that mean?
It means that its period didn't change.
Okay, so
1. So it can go right idea.
So let's say what would 2? I'm sketching so I can round it. What is 2 pi roughly as a number?
6.28.
So basically, if I start right here at my vertex, and I go over a little bit over 6, right? 1, 2, 3, 4, 5. There's 6. Just can go a little bit over, about 6 1/4. That's where it should end, right? So my graph, I should be able to somehow sketch. That's what my sine wave looks like. I would say sketch freehand because the bottom drops below -2, which is just because I'm sloppy. But you should be expected to be able to pull these pieces out and give me a rough idea what the graph's going to look like. Yes?
So why did it start looking over the y-axis?
Okay. So, you see where it says +1 right here? We always take the opposite sign of Houdini thingy, and that's where we start to weigh the thing at. So if there was no number here, we'd start at 0, 0.
So if it was like a -1, we'd start at +1?
You got it. Questions on that? Amplitude should be the easiest thing on this thing to figure out, right? Okay. You're going to have on your quiz next week, Wednesday, a couple of problems saying find the amplitude to this sinusoidal wave. And you have to show work to get credit. Now who can tell me what the amplitude is? 2. How do you show work? That's going to be hard because you guys should know the interpretation. So if this asks you find the amplitude and show your work, I would expect you to circle the number so I knew where you got the 2 from. That's all you have to do to show work. 2. That's where I found it. Yeah.
So in those problems, does it tell you the equation of the graph or just give the graph?
They'll give you the graph of like 2 sine 6 or 1/3 sine x, find the amplitude, and you would have to figure out it's 1/3. And circle where you got the information from. Then you've shown the work. That's all I need to see. If I just see 1/3, how do I know you're not done there guessing? I don't. Questions on that? Okay, once again, we are trying to create sinusoidal waves. So we need to figure out if we need to write a sinusoidal wave. It's easy as figuring out our ABCs. Please pay attention to that because I'm going to give you a complicated sinusoidal wave that you are going to have to calculate the A, the B, and the C by interpreting the graph itself to write as an equation. So, here we go. Yeah. 2 sine 3x plus 4 cosine x. That is the equation we need to figure out how to write as a sinusoidal wave. So let me pull that equation up. Okay. Graph it. We're going to call this a sinusoidal wave because it looks like a sine wave, but it's modified. You're my measurer. Your partner, Carson, is going to give you directions. Carson, you're going to have to come up to the board, please. Okay, with the blue marker. Carson, I want you to find a point on that graph that Clayton can measure the amplitude with. The amplitude. Clayton, please measure that. Find out what that number is. And we're only worried about the Y, so put that as your A. Perfect. Why don't you show him the closest to the y-axis and the negative C? Write that down as your x. Remember, we're going to do the letter C, yep. Remember, we're going to do the opposite sign. Opposite sign of it. Perfect. Now, he has to measure the phase shift. I'm not the phase shift, the period. Can you please help him find a complete cycle so he can measure the period? A cycle. Okay, stop. Put the start point of that on the x-axis and the end point on the x-axis. Okay, I need you to measure those two distances. Huh? what's the distance?
Goes from negative 0.369 to 1.75.
Yeah. So what's that distance?
Can't you just add?
Do
Add 'em?
not exactly add them.
2.094.
You're close, but you don't add them. You have to measure from one point to the other. You can add them if you get rid of the negative sign.
Yeah.
Okay, I'm sorry. I thought you.
Technically, you would subtract, don't you?
So what do you measure it at?
Well, you do 1.75 subtract.
No, it's not somebody should
Subtract.
add.
Yeah.
Negative.
Ignore the
I was
word,
thinking
yeah.
the same thing Bailey was.
Yeah.
Just add.
Yeah. Okay. So how far apart is that?
It's 2.094.
2.094. Can you put that, please? Yeah. So that's the length of your period, right?
Yeah.
Okay. So. My equation I am looking for is, what's the sinusoidal equation again? Rebecca?
Sinusoidal, oh, it's A sine, parentheses, BX plus C parentheses.
Did say
I did not finish it though.
So to write this equation, I got 4.472. That's my A. Sine, parentheses. She didn't actually find my B there though, did she? She actually found my period.
So that's so it have to be 2 pi over.
I thought it was 1.09. No, you have to do B over 2 pi.
2 pi over b.
No, because that equals period.
Well, here's the formula. Period equals 2 pi over b. So 2.094 equals 2 pi over b,
On both sides by 1.9 by 2.
or switcheroo.
Oh, what?
So we have
And if I multiply that through, I bet you I get.
something slightly less than. Oh, yeah. Well,
I now graph something that has nothing to do with sinusoid. It has, in fact, 2 different trig functions. Mind you, it only works if you use sine or cosine. It will not work with tangent. If you graph it with tangent, you're not going to get a sinusoidal wave. Carson taught us how to measure height. All I have to do is measure the height to get my amplitude. Then Carson showed us how to figure out the phase shift. And all we did is change the sign. And then do some complicated math, we were able to figure out B. 3. How cool would it be if I could show you how to figure out B without any complicated math at all?
pretty cool.
What did I say this number was?
3.
What number is this? 3. You know what's interesting?
Oh, it does. Oh, that's cool.
What number's right there?
3? 4? 3. I was thinking 7.
3.
So it doesn't change.
Oh.
No.
Okay.
So we just did all that.
What if they're different?
So I can find my period just looking from the X.
Yeah, that's a good question.
What?
What if they're different? Like, what if?
I don't know.
numbers?
What if they're different? Clayton, can you please change this to a 5?
Whoa. I guess. Oh.
Whoa, it's not a sinusoid anymore, is it?
No. What is that?
Oh,
That's
that's
like
like
a
a
really,
really- that's a
really
heartbeat.
bad EKG.
Yeah. Or like.
Here's a question, is it periodic though?
Yes.
Is it a repeating pattern?
Yes.
Yes.
So it's not sinusoidal,
It's periodic.
but it's still a repeating pattern, so it is periodic. So, great question. Is he really good to point out if these two numbers aren't the same, we don't get a sine wave.
So then you can't use the equation?
I can't use the equation because it was only good for sinusoidal waves.
Okay.
Great point. Okay. So, as I said before, if they give you a graph, they said, write it as a sinusoidal wave. Figure out your ABCs. Maybe that's why they use letter C, just because it's a memory thing. Or your AVHs. This doesn't all come the same, but it's more accurate. And you just write the graph. And no matter what I do, I can graph this and then trace and get my key numbers to get my thing figured out. Now, last third hour, we had a discussion. And the discussion was basically about, when do you ever use this in real life? What importance is this to you guys? And a lot of the really dumb kids in the other class said none.
That's kind of rude.
Yeah, I know. So I want to show you guys some practical use of this. Obviously you're not the scientist that made that, but you use the technology every day. And I'm going to give you guys a couple examples. For example, I remember over here in Brecken last weekend, she was super excited about Saturday because she could go sun tanning without any tanning lotion on because it was a UV index of 6. What does that mean? Great. So Carson has actually figured out that UV means ultraviolet, which means waves
Oh yeah.
so frequent you can't see them.
That's a really scientific term.
Did you give this explanation in your other class too?
Can't?
Yes.
Can't or
Can't.
can't?
You-
No, I didn't say their names.
You forgot the apostrophe T.
Oh yeah.
That is a new word.
Okay. So I want you guys to think about something. Ultraviolet means it's so fast you can't see it, but it carries heat in there. And basically, it is heat on a light wave that is going to be used to deep fry your skin.
Yes.
And you want it to come out the golden brown, so you think that's something desirable. Now, there's something we call sunblock.
It's really good for you. It actually like
So sunblock, what does sunblock PF 50 mean, or SPF 50?
sun protection factor of 50.
Which means I can take waves that are even 50 times faster, and it still will not get through that sunblock and start deep frying my skin.
Frequency of it's like what I want it to.
That,
No, you can still tan with sunscreen.
I know, but what it's doing is it's blocking those harmful waves
Yeah.
up to 50 times. Or if I, like I like to wear, I wear SPF 100.
Because he likes to be pale.
It's like white paint. Skin can't even, but what is it doing? It's blocking super fast waves. Once again, sinusoidal waves with very short periods, and they use that to design lotion to protect your skin against the sun. That is actual practical application of sine waves.
It's good. Or like
Yeah.
So if it's like SPF 50, does it block rays that come with frequency of 50?
50
Or-
times the frequency of the normal sun wave, or the normal wave.
Or couldn't you use like?
So,
Couldn't you use it in describing like music or sound, because like amplitude is usually related to
yeah,
volume.
we can use, we can think of other ones, what she said. This is just the example I use because it's so practical. So basically, it takes a wave and it compresses it and speeds it up so fast you can't even see the color anymore, but it still is carrying enough heat that it can actually crisp up your skin. That's on one end of the spectrum. What if I take that same wave
Make it infrared.
and I expand it so much that you cannot see it? It's not ultraviolet, it's the exact opposite.
Infrared.
Infrared, which is the reason your practical application. Elena, you want to give me that phone? The practical application and why you have to sometimes to change your TV channel. You might be sitting in the seat, and you change it and the channel doesn't work, and you actually have to move the remote a little bit higher so it has a more direct line of sight, because the wave is so long it can get blocked by different things.
That's how that works.
Yeah.
That's why I can't ever turn on the volume on my TV.
Probably because you somehow have the wave blocked from the remote to your TV.
Why
So
does the frequency change that? Why does the frequency?
That'd be more.
so what I'm trying to say is,
It's the amount of
anyone that's ever used a remote is actually using super long or super wide periods.
Yeah, but no one thinks about it that way unless you make the remote.
I think about
Okay,
it.
but what I'm saying is you're using waves in real life. That's all I'm trying to show you. In fact, here you go. Ready for this, Bailey? Real life application. It's true because Calvin McGillis said he saw it on TikTok. But I actually saw it work. We were over at Roscommon. We just called a basketball game on the radio. And I can't remember, was the playoffs in Roscommon for the boys or no? It was just a regular game. So we were broadcasting the game, and we're leaving the gym, and Jay Simon, he's the guy who does the broadcasting, wanted to hit the remote start on his car so he could start heating up the seats. Okay? So he stood there, and he went like this, hit the button, nothing happened. Hit the button, nothing happened. So what he did, as Clayton just pointed out, he used his head as an antenna. He put the button underneath his chin, and it amplified the wave enough that it could carry all the way to his car and turn it on.
What?
That does not work.
Ask Clayton.
That would work.
Because you're that makes zero sense.
It's full of water with
Yeah,
your
oh yeah. That would work. What? Can we do that in class one day?
All my keys are all that.
So, anyways, once again, the head amplified the wave because it has a dampening effect. The further away it goes, just like any ball that bounces, it dampened too much to get there, so the head had the wave start at a higher amplitude, and by the time it dampened, it was able to get to the car to make it work.
That's so cool.
How do you direct that? Do you like open your mouth or something?
I don't know if you open your mouth or not. That's a Clayton question. He didn't open his mouth. He just was. Yeah, you don't go.
Click the button.
I can give it extra momentum with the sound wave as long as the amplitude.
Maybe it'll work even extra.
Yeah.
Maybe your car like
Never
super
know.
Wouldn't that be cool?
super amplified.
All right. 4 words we're going to need to use in this assignment.
Amplitude.
Yes.
Amplitude, period, phase shift, frequency.
Right?
Yeah, you're right. It's fine.
Horizontal, vertical, stretch, and string. Horizontal, vertical, stretch, and shrink. Let's see if we can understand what that means. What's horizontal mean?
Horizontal would be phase shift.
Up and down.
Left and right.
I always thought horizontal meant this. Wait, it's like horizontal.
What's vertical?
Horizon, I told you. Yeah.
What's stretch?
Slash period.
Or bigger or increase? What's shrink?
Oh.
Smaller.
A trace.
Okay. So like in problems 1 through 4, problems 1 through 4, they're going to ask you to figure out the amplitude and describe what's happening mathematically. I'm going by memory. Okay, here's what I think number 4 said, and maybe off. -7/4. What's the amplitude? Amplitude's absolute value. That's 7/4. Because it's going to be 7/4 above and 7/4 below. It is flipped. So first of all, the negative flipped it.
What? It did?
Yeah, negative always flips your graph. That's what we did in one of your examples on your warm-up. Now, how does this affect your graph? Is it going to affect it horizontally or vertically?
Vertically, because all the points are being multiplied by 7 points.
And it's amplitude, and amplitude's up and down. Vertical's up and down. So it's vertical. And is it making it bigger vertically or smaller than a normal sine wave?
Bigger, because
Greater
it's
than
greater than 1.
So my amplitude is 7/4. It flipped and it vertically stretched. So that's the answer for number 4. Basically, you gotta say, did this number change it vertically or horizontally? How do I know? Amplitude is up and down.
Wait, how do you spell stretch? Did it get bigger or did it get smaller?
Let's see if this helps you. Vertical is amplitude. Horizontal would be your period. So stretch, if it's stretched, your amplitude has to be greater than 1, or your period has to be greater than 2 pi. If it shrinks, your amplitude is less than 1, and your period is less than 2 pi.
What if your amplitude is higher and your period is?
You can do multiple. You can have a horizontal shrink with a vertical stretch. Okay. Now, good news for you, especially if you're a track athlete. That's the lecture for the week. There's nothing tomorrow. Tomorrow you're going to work in class. Why? Because Monday, lucky you, will be doing the NWEA. Now please listen to me before I blow a gasket. I only have 2 left. I am running a deal. If you are able to either do one of 2 things, show 4-point growth from the fall, or get over 80% on the NWEA, I am giving you a 100% quiz to do with what you want. You can take that 100% quiz and replace any other quiz you've already taken this marking period, or you can put it in your back pocket and skip a quiz in the future and just put 100% in there.
What about our exam?
This has nothing to do with the exam. This is just my special deal, just for my class. Now the school has an exam policy, which you can also still do. So you can actually double dip. Or if you don't decide to get exempt out of the math test, you still get the 100%
Wait,
for the quiz. for a quiz.
So,
Think about your question for a second, and I'll get Sean a little bit more formed.
how do you see percentages
Yeah.
on an NWDA?
I'm sorry, I don't need percentage, I just need straight points. 4-point increase.
Oh, okay.
Yeah.
Imagine a tutor minus
Just
test.
What?
The ACCSB test. Yeah,
I
AP
tried
testing.
from.
Don't say
You
that.
said your fall one was lower, right?
Okay.
Does that mean?
It should be a Tuesday during Q&A.
It's not lower. I'm trying.
Elena.
So I already did my NWA for geometry, and I increased more than 4 points, but do I still have to do one for this last class?
Have you done one for this class yet?
No,
Or did you already
I don't
skated out of it because of geometry? Well, that's a geometry deal. Yeah.
So every single year, no, like I've been trying my best.
Right,
to
right,
make
right,
it-
right, right.
Yeah, it always gets lower though.
Yeah.
Like no matter what I do, it always gets lower.
Is it over 80%?
What's 80%?
It'll tell you if you're in the 80th percentile for mathematics.
Oh yeah, it should be like 99.
Then I guess you're not worried about it, because as long as you're over the 80th percentile for mathematics in the nation,
That's what I was wondering about the 80%,
You passed.
and then.
Yeah. Oh, okay, that's way better.
any questions about this?
What are we doing tomorrow?
392, 1 through 58
No, just work.
is your homework this week.
392.
Yep, it's on the sideboard.
1 through 50. Actually, 26.
Will our homework get passed back?
I usually do not pass it back. If you want it, I'll give it to you. But usually I just put it in the inbox. In my recycle box for this.